Welcome to Your Tutor Online video lessons. Today we'll look at how to simplify radicals. A radical is anything with a radical symbol, which looks like this. It can be square root, cube root, fourth root, or any numbered root. If there's no number in the symbol, then it's a square root. Otherwise, there'll be a tiny number here to show you what root it is. In this example, it's a cubed root. These expressions need to be simplified like anything else in math. Let's look at this example. Radical 54, or square root of 54. The easiest way I've found to simplify radicals is to do a factor tree for the terms inside the radical. Now this only works if everything inside the radical is multiplied together, or you only have one term. First, draw two lines out from the number or term inside the radical, and on this line we're going to write any two numbers that multiply together to give us our original. I'm going to choose 9 and 6. We're going to repeat the process until we have nothing left except for prime numbers. 3 times 3 is equal to 9, and 3 times 2 is equal to 6. Now we're left with only prime numbers here at the bottom, 2's and 3's. Now we want to look and see which root we're dealing with. Here it's the square root, or second root, because there's no number in the symbol itself. Since it's the second root, we're looking for groups of 2 of the same numbers. Here I see 2 3's. When you get a group, you can write the group number outside of the radical. In this case it's 3. Then we'll go ahead and write our radical and write everything that's left over inside, multiplied together. 3 times 2. Go ahead and multiply those together. 3 radical 6, and that's our simplified expression. You can look for shortcuts as you do your factor tree. As you get more practice with this type of problem, you'll know that 9 is a perfect square, and so its square root can automatically come out of the radical. For cube roots, you're looking for perfect cubes, and so on, according to whatever radical you happen to be dealing with. And it's going to get harder as you get into higher radicals, and you probably won't have higher powers memorized. But that's okay. You can just do your factor tree when in doubt. Let's look at how this works for a cubed root. We'll use the example cubed root of 135. We're still going to do the factor tree just like we did in the previous example. 5 times 27 is equal to 135. 5 is a prime number, so we'll just leave that alone. 27 is 3 times 9. And 9 is 3 times 3. Notice we could have had a shortcut there if you knew 27 was a perfect cubed. This time we're going to look for groups of 3 because we're dealing with the cubed root. Here you can see 3 3's. So that means a 3 is allowed to come out of the radical. So we'll write 3, the radical symbol with its cube root, and whatever's left over that didn't find a group of 3, which is 5. So this radical simplified is 3 cube roots of 5. Let's look at how to do radicals with variables in them. For a coefficient, we're still going to do a factor tree. 48 is 12 times 4. 12 is 3 times 4. 3 is a prime number. 4 is 2 times 2. And this 4 is 2 times 2. This time we're going to be looking for groups of 4 because we're dealing with the fourth root. So here I found 4 2's. So the 2 is going to come out, and the 3 will stay inside. Now let's look at our variables. This part's a little tricky. We're going to look at each of our exponents for our variables. We're going to take our root number and divide it into each of the exponents. The number of times that the root goes into the exponent will be our new exponent on the outside of the radical, and the remainder will be the new exponent that stays behind inside the radical. Now we can get started on our answer. We know a 2 comes out, so I'm going to write that. I'll leave some space, draw my radical symbol, which is the 4th root. I know a 3 is stuck inside. Now I can start dealing with the variables. 4 goes into 6 one time, so x to the first power is on the outside. 4 goes into 6 once, and there are 2 left over. So it's x squared left on the inside. 4 does not go into 2 any, so a y does not come out of the radical. 4 goes into 2 0 times with 2 left over, so we have a y squared left on the inside. 4 goes into 8 2 times, so we have z squared on the outside. 4 goes into 8 twice with no remainder, so there's no z left on the inside. And this is our final answer. 2x z squared times the 4th root of 3x squared y squared. Thanks for watching Your Tutor video lessons. Now I know today was a little bit of a tricky topic, so if you have any questions, head over to the blog and leave a question at www.yourtutoronline.com. Also, if you haven't been there yet, be sure to check out the quizzes I'm going to put up after each lesson and see how much you understood. Thanks for watching. Class dismissed.